Welcome back. We're at section 2.5 on markup and discount problems, and this time we want to take on the problem, what is meant by a discount? And what's the discount rate? Well, most people do recognize the idea of a discount. A discount means that something's been removed, taken away from some original cost. So let's give a more exact definition right here. A discount is the amount by which the retailer will reduce the regular price for sale. The discount rate is the percentage of the original selling price, which we just referred to, the regular price. So we take that percentage, and that's what gets removed from the original price. There's a couple of models that we can deal with right here. If we want the sale price, it's going to be the regular price, retail price sometimes we call that, minus the discount. So whatever the discount is the actual amount that is removed from that regular price to get your sale price. On the other hand, the discount rate, a discount itself will be equal to the discount rate times the regular cost. Well, let's go for an example to illustrate this idea. And in this problem, we're told that a CD player regularly sells for $400 is on sale for $340. Seems like a pretty good sale. Let's find out what the discount rate is. To do this, we're going to need a model. And here's our formula that we use in this particular case. We say that, remember, it's going to be the sale price is the regular price times the discount price times the discount minus the discount. Good Lord, I'm having a good day. Sales price is regular price minus discount. And the discount itself is equal to the rate times the regular price. So we're actually taking R minus D, the rate, the regular price minus the discount. R times R, small r, big R, right? We do want to make a differentiation. In math, small case or big case letters can make a difference right here. So let's figure out what we know and what we don't know, and let's fill in the blanks. What do we know? Our regular selling price is $400, and our sale price is $340. So let's see, S, that's the sale price according to the model above, is $340. So let's go ahead and fill that in. And that the regular price is $400. Whenever you're using a model, remember that the idea is that you should identify what you know and don't know before you start applying the model. And a good practice is to actually write the model. Our discount rate, R, well, we don't know that yet. So that's our unknown. So we're going to have to figure out what that is. So let's put in some numbers here. Let's see what happens. The sale price, $340, is equal to the regular price of $400 minus whatever the rate is times that original selling price of $400. Oh, there we go. Now we've got a variable to solve for, R. We're going to carry out the steps here. Let's start doing some subtraction. So we're going to subtract 400 from both sides in order to isolate our variable term. So we're going to subtract 400, here we go. That gives us 340 minus 400 is the same as the negative of 400 minus 340. The difference between these two happens to be 60, so we're taking a smaller minus a larger number. That gives us a negative. And that's equal to the negative of R times 400. Okay, so what we're going to have to do is we're going to have to figure this one out. Our rate, 400, we want to divide this. We want to divide both sides by negative 400 in this case to get rid of both the negative and the 400 and isolate R. So we're going to divide on both sides by negative 400. All right, so this is going to get R by itself, right? The 400 here will cancel with this 400, and our negatives cancel with one another, just leaving 1 times R. 60 over 40. Well, the negatives here will factor out here, right? Those will divide out because they're constant. So we can divide out. We've got 60 over 40. Well, there's actually a nice way that we could handle this. We know that 60 divided by 40, both numbers end in a 0. Whenever that's the case in a fraction, You can just reduce it out and say, well, this is really the same thing as 6 divided by 40. Right? Those 10s, that extra factor of 10 multiplies out. Now, we can continue to divide this out, so we can say this is the same thing as 6 is divisible by 2, giving us 3, and 40 is divisible by 2, giving us 20. So if we wanted to get our rate, we're going to have to take 3/20ths. Well, a rate, right, a percentage rate is something out of 100, and I happen to know that if you take 5 times 20, you get 100. Right? If we're looking for a percentage, we're actually looking for a fraction of something out of 100. So we're going to take 3 and multiply it by 5. That gives us 15. Well, 15 out of 100? 15 out of 100 means 15%. Right? As a decimal, it would become 0.15. So our discount rate here is, in fact, 15%.